of your functionality. For example, you probably don't want a single test case that verifies that your game launches, plays through every single one of its 100 levels, and shows the final splash screen correctly. But having a bunch of smaller test cases that can verify that it's correctly creating your starship and correctly handling the fire lasers method, and that your final game did complete screen, works correctly. Individual small things like that are better served as individual test cases rather than one just huge monolithic test case that's going to take forever to execute and the whole thing fails, and that's not too useful. And when you find a new bug, actually, think about writing a test case to verify your bug, maybe even before you've actually written the fix. It's basically, actually before you've written the fix is a great time to do it, because you can write a test case that you're writing it specifically because you want it to fail for the bug that you're trying to fix right now, so that you know that when you fix the bug, your test case starts working. And one of the great benefits of that is you fix this bug that you just found. Now you can be pretty confident that in the future you've not broken that bug, reintroduced it with some new change, because you've got a test case that verifies that your fix for the bug actually fixed the bug, so you'll notice if you break it again. And as we mentioned, it kind of complements the other types of testing, sort of more user interaction testing and real-world usage and actual larger scale tests done by a more structured testing organization, I guess. So it's not necessarily a replacement for that, but it's a good complement to it. So how do these things work, right? We've seen that it can sort of figure out which methods we've written that start with test. It seems a little magical. Objective-C is incredibly dynamic and provides some really, really cool things that let you do things like this, where the runtime can actually tell you what the methods are that it knows about. One of the caveats here, and one of the reasons I started out hesitating a little bit when I said we were going to talk about this, is that this is kind of what not to do. We'll get into it a little more at the end. There's great use cases for this and some really cool things you can do with it, but use it with caution. There are a lot of dangers around this area as well. So it's pretty low level, and you can pretty easily end up making code that's incredibly hard to maintain and really easy to break if you use this the wrong way. So having said that, let's take a look at all the cool stuff we can do. So how does OC unit find all those methods, right? And what else can we do? So user include obc is the place where you're going to get started with all this stuff. obc.h is basically the Objective-C header. It defines a whole bunch of stuff that the entire obc runtime uses. ID, nil. Capital nil is nil for a class. Lowercase nil is nil for an instance. They're both 0, so fun names. Capital bool, capital yes, capital no, all that stuff's defined in that header. Obc message.h defines a bunch of the low-level methods that are used for message sending. You may not have seen this yet, although you may have if you've been writing any code that's crashed anytime this semester. Obc message send has probably shown up in a backtrace if you've sent a message to an object that you've already deallocated. It's basically when you write a square bracket and a message send syntax in your Objective-C source file, what the compiler ends up turning that into is a call to the obc message send function. And there's actually a couple of them. There's obc message send, there's obc message send fpret for messages that return floating points, floating point values, obc message send stret for methods that return structures. But obc message send is probably the most common one. It's used for anything that returns an integral value or a pointer or an object. Those are all defined in obc message.h. obc runtime.h is probably the most interesting of all these in terms of crazy things you can do to the runtime. It basically lets you inspect and manipulate all sorts of different aspects of classes and protocols and methods. It can even let you do things like adding and replacing methods on classes at runtime. So while your code is running, you can actually add a new method to a class that you hadn't even defined on that class when you built it. And actually, that's how the categories on methods in obc work. You don't necessarily see this thing happening, but the runtime itself, when it's loading a new, so if it loads a framework that defines a category on a class that existed in your application, the runtime will actually dynamically insert these methods as part of the class when it loads that framework. All right, so let's take a look at some of the methods or functions you can use for this. This is probably one of the most interesting ones right off the bat. Class copy method list. Given a class and an output value where it's going to write out how many methods it copied, it will return you a malloc array of all the methods that that class defines. Once you've got those, you can then get things from them, like their selector. So method getName, given a method that we just got back from this function, will give us the selector used to call that method. Now, this is where we start to get into things a little bit that we glossed over earlier in the semester. We kind of talked about methods and talked about selectors, but we didn't really say too much about what their difference was. We kind of basically said you can consider them the same for all intents and purposes. That starts to not be true now once we start talking about this. So selector is going to be basically your abstract name that defines a way to call some method on your class. What that method is can be changed at runtime. And so they actually are two different things. And you can replace the method that is associated with a particular selector on a given class. So code that was compiled to call a particular selector may actually end up calling some different method at runtime if you've manually replaced it. Now, this is where we really start to get into the how to do this and don't do it kind of deal. But so basically, method get implementation is even one step beyond that, which is given a method, you can actually get an imp. And an imp is effectively a function pointer. This is the part that this basically would take all the dynamism out of all of the Obj runtime if you called things through this. You could basically get the implementation for a method, and basically you can use it like a function pointer and actually call the implementation of a method without going through the selectors and the entire dispatch. Don't do that. That's almost never what you want. The cases where it's useful are, I mean, there certainly are some, but don't do it. You can also call method copy return type, which returns basically a character string that defines the type that a particular method returns. And we'll see that in a header in a second. There's a bunch of, it's basically defined. There's one character that represents a particular return type, and we can take a look at that. Actually, let's get right into it. Close up our test thing here. All right, so I've already defined my Obj Playground app delegate here, and pretty much all my code is going to be written in here. So I've got my application did finish launching, and the first thing we're going to do is list all UI colors. So what we're trying to do is basically take a look at the UI color class and look through its list of methods that it knows how to respond to, or list of selectors it knows how to respond to, method list, and basically print out all the ones that look like they might return a UI color. So we'll take a look at our list all UI colors method. The first thing we're going to do is call that class copy method list function. There's also this one which we hadn't really talked about. The class that you pass the class copy method list is not the class that you get back from UI color class. You actually have to call this object get class function on it first. Then the thing that you get back from that you can pass to class copy method list. And we're going to get back that malloc array of methods, and we'll get back a count, which will be thrown into this unsigned int variable here that we've defined. And we'll iterate over all of them, but we want to make sure that since we're actually copying the method list, it's memory that we own. It returns a malloc piece of memory that we own, so we have to call free on it when we're done. So if we got something back, we'll free it when we're done. So we're going to iterate over all those methods. The first thing we'll do is, oops, this is wrong. Let's get rid of that. I changed this earlier, but apparently I changed it on the wrong computer. NS string, oops, NS selector from string. Nope, wrong way. NS string from selector. All right, so we've got our methods. We'll get the ith one out of there. And then we'll call method getName on the method that we got out. And that's going to return a selector. But we want to print this thing as a string. The thing that I just replaced was as an implementation detail right now is that a selector happens to be a string. It happens to also be a C string. Not really something you want to rely on. It is an implementation detail, and although probably won't right now, is certainly possible that it can change in the future. So there's a function defined that does that conversion for you. So you call ns string from selector and pass in the selector, and you'll get back an ns string. So in that case, we've got the method name string. We'll check to see if that string had the suffix color, because UI color defines a bunch of methods like red color, black color, gray color.